Unit 7 Force and Motion. Lesson 8 Force and Motion. Physical quantities associated with motion of a body. 1. Distance traveled and displacement. A body can move from the initial position A to the final position B through several paths. ACB, ADB, BEB, etc. Among these paths, the straight path ACB is the shortest. The body moves 4 meters due east from P to Q, and then 3 meters due north from Q to R. The actual distance traveled by the body is PQ plus QR equals 4 meters plus 3 meters equals 7 meters, but the shortest distance between its initial position P and final position R is the straight line PR joining P and R, which is 5 meters. 2. Uniform and non-uniform speed. When a body travels equal distance in equal intervals of time, the body is said to be moving with a uniform speed. It does not cover equal distance in equal intervals of time, then the speed is non-uniform. 3. Velocity. The rate of change of displacement of a body in a particular direction is called its velocity. Velocity equals displacement time. Velocity is just speed in specific direction. Its unit is also meter per second in the MKS system. Graph of linear equation. 1. Displacement time graph. The plot of displacement against time is called displacement time graph. In this graph, time is taken along the x-axis and displacement is taken along the y-axis. Displacement time graphs can be employed under various conditions, where objects move with uniform speed, non-uniform speed, remain at rest, etc. The velocity of the particle at any point can be found from the graph of its position as a function of time. When an object travels equal distances in equal intervals of time, it moves with uniform speed. This shows that the distance traveled by the object is directly proportional to time taken. 2. Velocity time graph. The plot showing the variation of velocity as a function of time is called velocity time graph. The velocity time graph for a body moving with constant speed in a straight line is a straight line parallel to the time axis as shown. The unit of force. The force acting on a body is equal proportional to the product of the mass of the body and the acceleration produced in it by the action of the force, and it acts in the direction of the force. Elasticity and plasticity. The external force which changes the shape and size of the body is defined as the deforming force. For example, when a rubber is stretched with an external force, the force acting on the rubber is deforming force, and the stretched state of the rubber is the deformed state. The property of matter by virtue of which it regains its original shape and size after removing the deforming force is called elasticity. The body which can return to its original shape and size after the removal of deforming force is called elastic body. For example, rubber, string, etc. Most solid materials exhibit elastic behavior, but there is a limit to the magnitude of the force and the accompanying deformation within which elastic recovery is possible for any given material.